Okay, we are live. If there is anybody in the chat section, please let me know. Am I properly audible and visible to all of you? Just give me a quick
Okay,
thumbs
we
up
are
in the
live.
chat
If there is
section,
anybody
guys.
in the chat section, please let me know. Am I properly audible and visible to all of you?
Just give me a quick
Okay,
thumbs
we
up
are
in the
live.
chat
If there is
section, guys.
anybody in the chat section, please let me know. Am I properly audible and visible to all of you?
Just give me a quick thumbs up in the chat
There is
section, guys.
anybody in the chat section, please let
Okay. Hi, Rajveer. Welcome back, guys. Welcome back to our YouTube channel, Geeks for Geeks, Gate Computer Science. So guys, in today's session, we are going to discuss basics of neural network, and we'll see that what type of question came in GATE data science mock exam, which IISc has launched, and how to approach these type of question. We'll see that in today's session, and we are going to see the basics behind any neural network and why we require neural network. We are going to cover all these things in this session. So guys, before starting the session, I just again telling you, you will say that every time I came here and tell you about this 390 challenge, because it's so good challenge for you as well as for your studies, right? Because in this 390 challenge, first, if you will take any course between 1st of January to 31st of January, you will get 90% of your amount refund which you have paid for the course if you will complete your course in 90 days, if you will complete 90% of the course in 90 days. So you can see that that brings consistency, right? Why it brings consistency? Because you have to complete that course in 90 days because you want that money back, right? So that would brings consistency, and it would also help you to get your money back. Okay, so it's a win-win situation for you. So if you have to take any course from GFG, then 1st of January to 31st of January is the best time, and you can connect with your friends or colleagues. You can tell them about this 390 challenge, so they would also take benefit from this challenge. Okay, yeah. So guys, in today's session, we are going to discuss about perceptron, right? So have all just let me know, have you heard about neuron? Does anybody know that what is neuron? In biology, all of we have studied that neuron is a cell which, let's suppose if I am touching a hot object, then neuron is transmitting the information to my brain that okay, the object is hot, I have to remove my hand, right? So brain would decide that I have to remove my hand, then neuron would proceed this information to hand, and my hand would get removed from there, right? So that's how neuron works. So in neural network, basically, in neural network, we want to machine in neural network in neural network we want machine to mimic the human brain. That neural network would work something like how human works, how human brain works. So that what we have to work on, neural network. So neural network teaches computer to process data in a way that is inspired by the human brain. So it is inspired by a human brain. We are going to discuss that in neural network. It is a type of machine learning process that uses interconnected nodes or neurons in a layered structure that resembles the human brain, right? So we don't have to do anything. We just have to work like how brain works, how neurons transmit the information to the brain, and then brain decides what to do. We have to work like that. So we want to make a machine learning model like that, so that it would decide by its own, and it would take its decision like human brain does, right? So that is neural network. Okay, so if there is any doubt at any point of time, you can let me know in the chat section, guys. See? Okay, next we have is perceptron. So guys, perceptron, so I told you what is neuron help me to transmit information to my brain. So perceptron is a single unit of neuron, right? If I'll take single neuron, we call that perceptron. So A perceptron is a basic building block of artificial neural network. We'll see that how it would work. So first of all, let's suppose to understand a perceptron, we are taking an example here that a student studies 7 hours, play 3 hours, sleep 7 hours, then he would get he or she would get pass, right? A particular student who study 4 hours, play 6 hours and sleep 8 hours, he or she would get fail. Next example we have that a student study 8 hours, play 2 hours, sleep 6 hours, then he or she would get pass, right? So we have this information. Now I want to know, let's suppose any new data came. Let's suppose I have this data. If I'll take here 6 hours of study, no, 16 hours I am taking in total, 6 hours of study, 4 hours of play, and then 6 hours of sleep, then student gets pass or fail. Then how would I decide that student gets pass or fail? I do not know any information right now, so what would I do? So let's suppose I'll take these features, like these are the features, and I can see that this is a classification problem, right? Because I have a feature x1, x2, x3, and I'm getting a result that students get passed on the pass or fail. So that means initially I'm giving three features and I'm getting an output, right? So this is my supervised learning. So what would I do? I'll take a features x1, x2 and x3. These are my features and I'll take a perceptron here, right? What perceptron does, if I'll pass through this x1, if I'll pass all these features through this perceptron, it would added one weight w1, w2 and w3. It would multiply weights with these features and add a bias function, right? So we have a bias function here. So half of this perceptron gives me value z is equals to w1x1 plus w2x2 plus w3x3 plus b, right? This half of perceptron does. Then again it moves forward and it passes through an activation function. Activation function is sigma of z. So we have heard different type of activation function, and we are going to study different type of activation function in this video as well, right? So this is my sigma z. Sigma z is an activation function. And why we have used this activation function? Because z is a numerical value we got, and with the help of this z I want that student get pass or fail, like we have done in logistic regression, right? So I have taken this. If I'll pass through this sigma z, if I'll taking sigmoid function, activation function, here I'm taking sigmoid. So what would I get? 1 upon 1 plus e to the power minus z. And I know that this sigma z lies between 0 to 1, right? And I know that here if sigma z is greater than 0.5, then student gets passed. That means I'll get output 1, and sigma z is less than 0.5, this is 0, right? So I'll get an output here, output, right? So now you would ask that why I am doing all these things, why I am studying perceptron. I already know that if I'll this is nothing but a logistic regression, right? I already have studied this, but right now you just only have added this term which you called as perceptron, right? So anybody have any idea that why I have done that? Just let me know, guys, if anybody have any idea that why I have introduced this perceptron term. So guys, if I have a single neuron, that means if I have a perceptron, then it is nothing but a logistic regression. But in certain cases it would require that we want number of outputs, uh, number of neurons. I require number of neurons, then it would help me to get in better output rather than my logistic regression. So let's take one example. uh, okay, let's take one example. Okay, so if I'll take one example, if I want to know that price, that just huh, let's take one example that I want to know that probability of cloth being top seller, right? I have some clothes in my studio or anything. I want to know that probability of that particular cloth being top seller or not. So how do I know? So I have number of features. So what are the number of features I have? I have price of that particular cloth. I have the shipping cost. Prices, instead of prices I'll take price here. I have price, I have shipping cost, and I have market value, that what would be the market value of that particular product and in which price I am selling, right? That is two different things. Price and market value is different. That other products market value, what would be that market value would be that, or let's not take this, it would get more complex. Let's see how much marketing cost I am having for that. I have added that value as well. And then I have material, or that how much marketing I have done to make that particular product popular, right? And then I have here is material, that what kind of material I have used. So I have four features and I want to find out that what would be the probability of cloth being a top seller or not. So one would be my logistic regression, right? What would I have done using logistic regression? I have taken these features x1, x2, x3 and x4, and I have find out w1 x1 plus w2 x2 plus w3 x3 plus w4 x4 plus b, and I'll pass through, I'll get this z value, and I'll pass through this sigmoid function, right? I'll get the probability that I'll get a value between 0 and 1, which would give me the probability of a particular product being top seller or not, right? That is one condition. But I know that uh, if I want to get better results, if I want to get better results, so what would I do? I'll add number of neurons. If I'll take single perceptron, single neuron, that is perceptron, then I'll get a logistic regression. But instead of that, if I'll add three neurons, and these three neurons named affordability, awareness, and then perceived quality. So you can see that I have added three neurons. Now these features pass through these three neurons, and then we'll get we'll get the output, right? Then we'll say that, then we'll get better result. So you can see that if I'll talk about affordability, then prices would matter for affordability. If I'll add shipping cost, so affordability, shipping cost should pass through affordability. But if I'm talking about awareness, then because of marketing I would get awareness, and material is what, but my perceived quality, right? And perceived quality also comes from price, that in that particular price I am getting what quality I want. So you can see that here, instead of passing through a single neuron, I am passing through three neurons here, right? And three neurons playing its role. So you can see that when I talk about affordability, I'll find out, when I was talking about perceptron, I'm taking only single neuron and I'm passing through it. Now these x1, x2, x3 four features I have, and for this affordability, right? So I'll add here w1, and this would be w2. Let's write down here 1, because it comes for affordability. So can I write down here w11 x1 plus w21, and we'll add one bias b1, right? This would be my z1 value. I'll name this z1 value. Now for this awareness column, you can see that awareness is coming through marketing, right? x3, so I can write down only x3 here. So z2 would be w3 x3, or I can write down 2 value here, w3 2, because it comes for my second neuron, right? It's basically only representation of neurons. Now for this perceived quality, that means I am finding out here z3, right? What would be the value for z3? You can see that material and price. So I can write down here x13 w sorry w13 x1 plus W2 3 x4 and plus B3. Here I have B2 as well. So I get Z1, Z2, Z3. Right now you will ask that what would I do for Z1, Z2 and Z3? Right? What would I get? Rajveer is asking there were few questions of NLP in All India mock by GFG that is not in the syllabus. Uh, NLP questions last Sunday, the mock which we had. Can you share that in the chat section so I can go through it and see that which of the questions is not in syllabus? Okay, so now you can see that I got Z1, Z2, Z3, and I know that what each perceptron does, it gives me sigma Z1 value. So Z1, if I'll get here sigma Z1, sigma Z2, and sigma Z3. Right now, what would I get? I'll get an output using this sigma Z1. Let's take this sigma Z1 as, let's say H1, sigma Z2 as H2, and sigma Z3 as H3. Now I'll again apply the, I again apply through these three values to a perceptron, right? So from here I'll get, let's say I'll take, uh, let's take, from here I have taken up to W3. So let's take W4H1, W5H2, and W6H3, and then add one bias function, let's say B4, right? So here this Z4 value I get, and I'll pass through this sigma of Z4, then it would give me probability of a cloth being top seller or not, right? It would give me the probability of cloth being top seller or not. So you can see here, when I'm passing all the features, only one perceptron, or I'm applying my logistic regression only, then I'm getting, uh, I'll get less, I'll get less accurate solution rather than in this. And now you would say that, but I am getting a probability, I do not want to do that. Let's suppose if you want, if you are getting an accurate solution, I'll tell you further that if you will get large and large data set, then your logistic regressions would not work. Let me show you one diagram which would help you. Just let me know if this is clear. And guys, let me tell you one thing, if I'll move from left to right, this called as forward propagation. Forward propagation. So what is happening here? I am starting from the left, then I am adding weights and adding a bias function, and then I am passing through another neuron. What is the purpose? Okay, right, Rajveer, these questions. Okay, let me talk to the team and let me see that why these questions were there. I'll check these questions. Let me take a quick screenshot of those. Yeah, I have taken a notice of all these questions. Thanks, Rajveer, for the feedback. I'll look into it. Okay, so what is happening here? If that means adding a, multiplying a weight to a features and adding a bias function is forward propagation, right? And then passing through its, passing through the activation function, and here I have taken activation function as sigmoid function, and then passing again. There can be multiple layers, and we call that as a multiple layer neural network or multi-layer neural network. So I can say that, so we have already discussed what is a perceptron. A perceptron is a basic building block of artificial neural networks. Perceptron takes a set of inputs, applies weights to these inputs, sums them up, and then passes the result through an activation function to produce an output. The simpler neural network model has only one perceptron, and this, if a simple neural network has only one perceptron, then it would become our normal regression problem, right? Okay, so this is the example. What we have done, we have M features, we have applied weight to these, and then we have passes through the sigmoid function, and or we can say that net input function or activation function, and then we'll get an output. Right? Forward propagation, I told you what we have done in forward propagation. First we have input layer, then I have multiplied weight with features, multiplied weight and add bias, right? And then passes through an activation function, activation function, and I have done for each of the layer, right? Each of the layer. So let's suppose if I have a multi-layer neural network, we have these features x1, x2, xm. These are my features, and these are my number of neurons. Here we have 3 neurons, then I have 4 neurons, and then I have single neuron, and then I have an output. Or there can be an output as a vector, and by the vector I mean that there may be, in my output layer there may be more than one values if it requires, right? So if I'll take here 2 neurons here, right? So what would happen? So you can see that each of would goes here, and each of would go for this one, right? Similarly for this one, and then this would go something like that, and this would like that, and this one, right? And this one, right? And then I have here, so you can see that, right, this kind of neural network I can get. But more number of more number of layers would help me to get better and better solution, right? And if we have large number of data set, it is not possible for me to get a good solution using machine learning model. We have to move to neural network, right? We have to move to that. Okay, so that is my forward propagation. Now next thing is backward propagation. So guys, let me tell you what is backward propagation. We were working with this example when we have started. I told you we have 3 features, x1, x2, x3. This is study, it is x1, this is x2, and this is x3, right? We have one perceptron, and with this I get one output. This is x1 feature, x2 feature, x3 feature. We have added weights, w2, w3, and we have one bias value here. So I can write down here z is equals to w1 x1, w2 x2 plus w3 x3 plus b, right? And then I have passes through the sigma z value, right? And I told you that if sigma z is greater than 0.5, I'll get one value, and sigma z is less than 0.5. If it is greater than 0.5, then I'll get one value, and sigma z is less than 0.5, I'll get 0 value. I already told you all these things. Now I told you that I want to know that if a student studies 6 hours, play 4 hours, and he would sleep 6 hours, then he would get pass or fail. I want to know that, right? So what would I do if I have trained my model on this neural network? What would I do? I'll pass this 646, right? I'll pass this 646, and it would give me the result. But before that, I want to know, I want to test my model that it is working right or not. So what would I do? If you generally know, we usually divide our data set into training set and test set, right? So let's suppose this is my training data and this one is test. So I'll give 8, x1 8, and x2 2, and x3 6, right? So there might be a possibility that it would give me 1. If it would give me 1, then that means accuracy is good, right? I can find out find out on all the test data. If it would give me 0, then you can see that the value here is 1 and I'm getting 0, then that would be my error. So error function would be, in this case, error function would be cost function, or I can say that loss function, anything that would be y minus y cap, right? I have to minimize this error. So for that, what would I use? If you remember, we have used gradient descent to minimize this. We have other methods as well, but let's suppose if I'm working on gradient descent, so what would I do? I'll take how do I work on gradient descent? That means I have to find out W1, W2. That means I have to minimize first this cost function, minimize this cost, right? And how do I minimize this cost? I'll find out this W1, W2, W3, and B, such that this function gets minimized, because x1, x2, x3, I already have that. The value which I have taken by myself are W1, W2, and W3, right? These three values I have taken myself, x1 and B, four values I have taken by myself. So I have to train my model over these four values, right? So can I say that here my trainable parameters are how many trainable parameters? I have four trainable parameters, right? I have four trainable parameters here. So that's how we'll find out number of trainable parameters. So let's suppose instead of one neuron I'll get four neurons, and I'll to have two neurons. Then how many trainable parameters I have? Can anybody tell me how many trainable parameters I have? And I have one more neuron here which would leads to output. So I have three neurons, two neurons here, one neuron here. Can anybody tell me that how many trainable parameters are here? So guys, you can see that here, because we have three wi's and one b. So four for this neuron and four for this neuron, and then I'll get here value h1 and h2. So here, because of these two neurons, I have to find out here another z value, which I call it h1, let's say w1 dash, plus h2 w2 dash, and plus b dash. So that means I'll get three parameters here, w1 dash, w2 dash, and b. So three trainable parameters here. So in total I have 4 plus 4 plus 3. That means 8, 9, 10, 11. So I have in total 11 parameters to train. So I hope you understand that how to find out number of trainable parameters. This was the guys, we have one uh, parameter, one neuron here as well, because you can see that I want to get a single output that either pass or fail. So that's why all the neurons pass through it, right? These two values also pass through it. I hope this is clear that why 11 is the answer instead of 8, as you guys are answering 8 as an answer. Okay, let me know guys if there is any confusion. Okay guys, I told you one example. Now, I was telling you backward propagation. So that means I'll update the value W1, W2, W3, WB. So by updating these values, that means I am backtracking. So first of all, I'll add the output, right? I'll add this output. So I am getting different output. So that means I have to minimize this cost. So first I'll minimize this W1 dash, W2 dash, and B. Then with the, because they are minimized, so H1, H2, H1 and H2 are here, they should also be minimized. So this value H1 I am getting because of W1, W2, W3, and B. H2 I am getting W1, 1, W2, 2, like these. So all these WIs has to be minimized. It has to be trained in such a way that I'll get a minimum error, right? This is called backward propagation. If I'll move backward to get to update my parameters, my trainable parameters, this we call as backward propagation. I hope this is clear to everybody. Okay, so guys, just let me know what would be the number of trainable parameters in the problem I have written down here previously. The problem was price, and then we have what we have, shipping cost, marketing, and we have quality, material. Then we have here affordability awareness, and then we have perceived quality, and then we have one another neuron which would give me probability, right? So price comes for afford affordability, and it goes to perceived quality. Shipping cost, affordability, shipping cost, okay, marketing for awareness, material for perceived quality, right? This is the diagram we have, and we'll use all these three features to get an output. Can anybody tell me what would be the number of trainable parameters? How many uh, how many trainable parameters I have here, guys? Here we have 8. Okay. Anyone else, guys? Anyone else? Okay, Rajveer is saying 9. Okay. So, guys, first of all, 2 WIs I'll get here, and I'll get one bias function, and here only one feature is coming, so 1 plus 1, 1 wi and one bias function, and here 2 plus 1, right? So in this layer I'll have 3 plus 3 6 7 8. I have 8 features here and 8 wi 8 trainable parameters here, right? So you can see that in this layer I have 8 trainable parameters, but I just want to find out probability of a cloth being a top seller or not. So I want a single value. That means I have to pass through one more neuron, right? Then I'll get an output, right? This is also a neuron. So that means in this neuron, how many trainable parameters? 3 for these features coming in. Now let's forget about this previous layer, right? I only have this data, right? Now for this one, I have 3 features: affordability, awareness, and perceived quality. For these 3 features, I have 3 weights, and one I have bias function, right? So in total, we have 8 here and 4 here. So 8 plus 4, that means 12. Guys, check it once, then it would be 12 instead of 9. Just don't understand that why you got 9. Let me know, guys. Let me know, guys, if there is any confusion that why it is you guys are seeing 8 and 9 as an answer, because 12 would be the answer. Trainable parameters are 12. Okay, so let's move forward. I hope there is no confusion. Okay, this already we have discussed. So guys, I told you that this is my multi-layer neural network, right? So if I'll move in this direction from left to right to find out wi's, uh, and multiply it with feature and add a bias function and then move to the output, that is my forward propagation. And if I'll work using loss function, that means want to minimize the loss function. For that, I'll use gradient descent. That means I'll try to update all the values of wi and b, and that would call my backward propagation. Because to minimize a z value here, I have to minimize w1 and h1. Let's say here I am getting a value h1, h2, and h3, right? So w1 h1, w2 h2, w3 h3, and b. Because w1, w2, w3, and b are my trainable parameters. h1 h2 h3 are comes from here. I have to minimize this as well, and h1 get minimized. So there are one, let's say n plus 1 features in this, and n plus 1 feature, n plus 1 feature. So all have to be minimized, all have to be updated with the help of loss function or using gradient descent. Can anybody tell me how many trainable parameters in this? How a gradient descent differentiate between a true and pesky, true minimum and pesky saddle point. That means we are getting local minimas. Actually, just tell me once that how many trainable parameters in this, then we'll discuss that. How many? Let me move aside. Just let me know, guys. Here I have n features, n features x naught, x1, and x naught is, it is taking as a b x naught. Okay, we have n plus 1 features here, guys. In this we have n plus 1 features. Okay, here we have n plus 1 features. So that means you can see that here we have n plus 2 trainable parameters, n plus 2 trainable parameters, n plus 2 trainable parameters. So in this layer, in this hidden layer, we have 3 into n plus 2 trainable parameters. And in output layer, guys, it would not be cube Akhil. Here we have n plus 2, 3 into n plus 2, n plus 2 plus n plus 2, n plus 2. And here we have 3 plus 1, that is 4. That means in total we have 3 into n plus 2 plus 4. That means 3n plus 10 trainable parameters. Guys, this was a question, similar type of a question we have in GATE. Now, Rajveer is asking that how gradient descent differentiate between a true minimum. That is a problem gradient descent face. Because let's suppose if we have a single minima for a function, right? So I know that how this gradient descent work. So let me tell you what is a formula for gradient descent. So let's suppose I have to find out new value of wi. Let's say w1. So w1 minus del z, or let's say what is a cost function, del j by del w1 and into alpha 1, right? So if j is uh, j is on the left hand side, that means you can say that this is a cost function for this is a cost function graph. So let's suppose we have we are at this position, right? Then you can see that this curve is decreasing. So del j by del w, you would get negative, right? Because the function is decreasing. So this would be a negative value. So negative negative gets added. Alpha is what? Learning rate. So you would take it by self. The step, the step size you have to take, you would take as alpha, right? So if you will multiply del j by del w1 with alpha, you will get a negative value, negative negative plus. So you will get w1 gets added with some value. So you would reach here, right? Similarly, let's suppose we are at this position. So what would we do? Del j by del w, because the function is now increasing. You can see that. So this del j by del w is positive. Why it is increasing? Because as we increase the x value, this z function is increasing as we moving to the right hand side. So this function is increasing. Del j by del w be positive, and this would value become positive value. So we are moving the w1 to the left, right? So that's how gradient descent works. If it is here, it would move something like here. But yeah, the problem is if we are getting a saddle point or if we are getting a local minimas, then it would create a problem. right? So we'll that in future, that how would we going to perform that. Akhil is asking why n plus 2, because you can see that just I have named my feature from x naught to xn, right? So we have n plus 1 features, so that's why n plus 1 features and one bias function. I hope this is clear. Okay, so that's how multi-layer neural network works. Okay, guys, tell me how many trainable parameters in this neural network. Now you can see that I have two hidden layers instead of one. Just tell me how many trainable parameters here. Again, guys, we have n plus 1 features. You can see that x naught to xn. We have started naming our feature from x naught. Some of the books started from x naught, some of the books started from x1. So just see in the question if it comes a question like that. Just tell me, guys, how many trainable parameters. Just try this one. Okay, so guys, here I have n plus 2 features, right? N plus 1 features I have, and one would be bias, right? So n plus 1 weights and one bias, and n plus 2 here and n plus 2 here. So in this hidden layer I have to train 3 into n plus 2 for this, for these two features, because three features. Now let's forget the previous model. Now I have three features here which is going to this neuron. So that means three features and one bias. So 3 plus 1 and 3 plus 1 here. So in total I have 4 plus 4, that is 8 from this hidden layer. And for this output layer I have two neurons, two features. That means two features. For that I have two wi's and then one bias function. So I have three value here. So in total, if I'll calculate 3 into n plus 2 plus 8 plus 3. So how many trainable parameters? 3n plus 6 plus 8 plus 3. That means 3n plus 17 would be number of trainable parameters. I hope this is clear that why 3n plus 17 would be trainable parameters in this case, guys. Just let me know, guys, in the chat section if you guys having any problem. You guys facing any problem, just let me know. Otherwise, let's move a question which is from, okay, but first let's see that. So instead of discussing that it would improve my accuracy, we generally face this confusion that why we add number of neurons, why we are not working on linear regression, logistic regression, on the all the models which we have studied in basic machine learning. So that's the proof of that, that why we are not doing with the help of normal machine learning model. So you can see that we have a lot of data if we have to train a model. So if we have a volume of data in megabyte, so you can see that traditional machine learning model gives me this performance, right? Green curves, green line shows me that that how is the performance, that at a certain point, if I'll start from 0, it increases, but if I'll feed more and more data, it would become linear, right? There is no increase and decrease in the performance. So it is not helping me to give more and more data. If for a machine learning model, if I am giving him lot of data to learn, so I want that it would perform well, right? If I am collecting all my data or all the data analysis people in my company are working on collecting the data and refining it and doing all those things. So I want that my machine learning model would work well, but here it is not performing well. So that's why we move to neural network. So but in neural network as well, we have three types of neural network: small neural network, medium neural network, and large neural network. So as we increase the neural network level, we get the increase in performance. So small neural network gives less performance as compared to medium and large, and medium neural network lies between performance lies between small and large, but large neural networks is increased, right, if I'm giving large and large data. So we usually say that neural networks works well if we have large amount of data set. If we have low amount of data set, so you can see that large neural network is performing bad than medium neural networks. So if we have a small data, then we have to decide, we can't take more and more neurons in that, more and more layers in that, right? So that is my performance graph of machine learning model, traditional machine learning model, and neural network. I hope this is clear. If this is clear, then I have one question which all of you guys, I think, already have solved it. It is a question from Gate CS mock. Let me know what would be the answer for this. So here I have considered a multi-layer perceptron model with one hidden layer and one output layer. Hidden layer has 10 neurons, output layer has 3 neurons. Input to the MLP is a 5-dimensional vector. Each neuron is connected to every neuron in the previous layer, and a bias term is included for each neuron. The activation function used in the sigmoid function. Okay, activation function they have used is sigmoid function. Then the total number of trainable parameters in this machine learning problem is, okay, multi-layer perceptron model is, guys, I hope all of you have solved this question. Just tell me how many trainable parameters is there. Okay, so let's see, guys. If I have a 5-dimensional vector, that means I have 5 features, 1 2 3 4 5, and I have 10 neurons in the hidden layer, and I have only one hidden layer and one output layer. So you can see that each of the 5 features would move to each of the neuron, because they are saying that the input, each neuron is connected to every neuron in the previous layer, right? Each neuron is connected to every neuron in the previous layer. So in that particular neuron, neuron, how many trainable parameters? 5 wi's, because 5 features I have, and one bias term, 5 plus 1. Similarly 5 plus 1, and each of the neuron we have 5 plus 1. That means 10 into 6, right? Because we have 10 neurons, and each of the neuron has to work on, has to train 6 parameters. Now all these 10 parameters would move to this output layer. Now if I'll forget the previous data, now these 10 features moves to this particular perceptron, right? So that 10 wi's I'll get for each feature. I'll get 1 wi, and then one I'll have one bias value, right? So I have 10 features and one bias value. So 10 plus 1, that means 11. So 60 plus, I think, just give me a minute, guys. Hidden layer has, okay, sorry. Output layer has 3 neurons. Sorry, guys. Output layer has 3 neurons. I haven't seen that. That's why I'm not getting the correct answer. Output layer has 3 neurons, right? So 10 into 6 was correct. Now for this one, Again, for this one, all the 10 neurons are connected, so 10 features, WIs, and one bias term. And for this one as well, for this one as well. So that means plus 3 into 11. That means 60 plus 33. That means 93. So total 10 trainable parameters are 93. Right, Rajveer. 93 would be the answer. Hidden layer parameters would be 60, and further we have 33. Okay, yeah, let's see further. Guys, we have this data set. I am taking this data set to show you how these operations would work. So let's suppose I have this data, and I have this features I1 and I2, and I have two hidden layers. This is H1 and this is H2, and then we have two output. You can see that T1 and T2, two output layers, and I1 connected with all these are connected, right? It is connected like this. So let's suppose I have to find out H1. So H1 is, first I have to find out, let's say I have to find out Z1 I1, sorry, W1 I1 plus W2 I2 and plus B1. And let's take it as 1. Why I am taking it 1? Because I have to take for this next H2 as well. And then I have to, so let's suppose initially I can take any W1, W2. Initially I can take any W1 and W2. So let's suppose I am taking W1 as 0.15 and W2 as 0.20, and then B value I am taking as, let's say, 0.35. So I'll get this H1 dash. Let me tell it, let me say H1 dash, because after that I'll apply sigmoid function. Let's take it, instead of H1 dash, let's take it Z1. So if I'll take W1 1, W2 1, or instead of that, let's take it like that, W1, W2 and B1, right? So if I'll find out, so you can see that for the first feature I have I1 0.05, 0.10. So I'll write down 0.15 into I1 is 0.05, 0.05, and W2 W2 is 0.20, I2 is 0.10. I am working on this sample value, right? And then B1 0.35. So if I'll solve this, I'll get this Z1 value. So on solving, you will get the Z1 value, that is 0.3725. I have already solved it, so I'm just not wasting your time in calculation. You can find out by yourself. Let's say activation function is sigmoid function, so that would give you the value. So I'll get this give value I'll get for H1, 1 upon 1 plus e to the power minus Z1. That means 1 upon 1 plus e to the power minus 0.3725. So if you will solve this, you will get 0.59, right? So H1 value you get as 0.59 for this first sample. Similarly, you can find out for second sample, right? Similarly, you can find out a value for H2 by deciding W1 and W2. So you should know all the calculation, right? It would help you. So just see that how we'll go through it. First we'll find out Z1, and then I'll apply activation function. Now you would ask that, ma'am, so many times you have said that, okay, I'm taking here activation function as sigmoid function. What are different other activation function? I haven't told you, right? So would you know that different types of activation function? Just let me know what are different types of activation function we can have here. Just let me know, guys. So I hope all of you understand this calculation, right? So similarly, you can do for H2. They can ask a basic calculation like that. So you should know that how these parameters calculation works. I already told you forward network. Okay, yeah. Tell me, guys, how what are uh, different types of activation function we have. Okay, anyone else, guys? Other different type of activation function? Okay, 10 hyperbolic ReLU. Rajveer has said two activation function. Any another activation function you guys know? Okay, so first basic sigmoid function I know is activation function is sigmoid function. Sigmoid function is if sigma z, I'll represent this value with sigma z and I'll say that 1 upon 1 plus e to the power minus z, and it graphs, it lies between 0 to 1. E to the power infinity 0. Okay, not like that. Just give me a minute, guys. Yeah, z0 1 by 2. Okay, I usually get confused in this graph, guys. Just give me a minute. Yeah, this is a graph. Okay, finally got it, guys. The graph for sigmoid function. Next we have is threshold activation function. Threshold threshold activation function. Right? What is the threshold activation function? It would give me the value 1 and minus 1. If x is greater than 0, it would give me 1, and x is less than equal to 0, minus 1. So you can see that when I want output as 1 and minus 1, then directly 1 and minus 1, then I can use threshold activation function. So if I'll talk about the graph, this would be a graph for threshold activation function. Right? Next activation function we have is unit step function. Unit step function. So it would leads to either 1 or either 0. If x is greater than equal to 0, it would gives me 1, and x is less than 0, it would give me 0. So for negative value it would take to 0, and for positive value it would take to for negative value it would take 0, and for positive value it would take 1. Right? These three types. Any another sigmoid function? Okay, so let's see other sigmoid function as well. Then we have ReLU. Right? This is one of the important sigmoid activation function in uh, neural network. Right? What is this ReLU? It says that f of x is equals to maximum of 0 comma x. So that means it would gives me always positive result. Right? So the graph would be something like that. If I have negative value, then the maximum would be 0. Right? Otherwise it would, the maximum would go like that. Like this is my ReLU, and we call that rectified linear unit. ReLU is rectified linear unit. Next we has this linear activation function. Linear activation function. This is one of the activation function, but it does not work in neural network. It is basically f of x is equals to x. It graphs like that. So if we have, it passes through the center. Right? This is linear activation function. Can you tell me, guys, that why we do not use linear activation function in neural network? This linear activation function. Anybody? Can anybody tell me that why we do not use linear activation function in neural network? Okay, just try to find out that. Because if you will see, we are here passing through neurons. Let's say here I got w1x1 plus w2x2 plus b, and if I'll pass through this through an activation function, I'll get as it is this value. And let's suppose from here I am getting w3x1 w4x2 plus b2, and here b1 w5x1 w6x2 plus b3. Right? If I'll pass through again through a neuron, right? So let's say if you will get here h1 h2 h3, because Now this value would be we'll keep as it is, right? Now this h1 would be, so I'll multiply, let's say I'm taking activation weights value as w7, w8, w9. So I'll multiply it with w7, w8 with h2, and w9 with h3, and add a bias function. So what would I get? Again I'll get a linear function, right? And this I can simply do using linear regression, so I do not need to use this value, this neural network, this whole neural network, right? What would I get here? I'll get here h1 w1, h2 w2, sorry, h1 w7, h2 w8, and h3 w9 plus b4, right? If you will fill the value of h1 w1 x1 plus w2 x2 plus b1, and value of h2 w3 x1, like if you will fill the value, you what would you get? Then w7 into w1 would become new w1 dash, w7 into w2 would become w2 dash. So that means I'm getting only new weights, that is w1 dash, w2 dash, w3 dash, w4 dash, w5, w6 dash, right? So this problem gets reduced to normal linear regression, right? So it gets reduced to linear regression, so there is we'll not get any kind of benefit adding neurons here, right? So that's why we do not use linear activation function, right guys, because we want non-linear patterns. And yeah, okay, next we have this last activation function. There are many more, but I told you the famous activation function, that is hyperbolic tangent activation function, right? Which you call as tan hyperbolic as well. Tangent activation function. Hyperbolic tangent activation function. And how would we define it? We'll define f of x. We'll define f of x is equals to e to the power x minus e to the power minus x upon e to the power x plus e to the power minus x. And it would also give me value between minus 1 and 1. And if you will see the graph for this hyperbolic, it would be something like that, right? So you can see that it gives me value between 0 and 1. The sigmoid function, if I want a value between minus 1 and 1, instead of sigmoid I can use hyperbolic activation function. So these are the activation function I have. So I hope this is all clear to you. Just let me know guys if there is any confusion, otherwise we'll end this session. So we have this in total. I have added this question, you can check by yourself, just trying to find out the values for x1 and x2. I have taken it from a book, just try to find out by yourself. Okay, yeah, so that's all from my side guys. All the best for your exam. So just try to solve questions, right? Just try to do some calculations by your hand, so that if there is some calculation question in exam, you would be able to do it. Okay, yeah, so that's all from my side. And guys, at the end I just want to tell you that if anybody of you want to have a course, if any of your cousin friend want to buy a course first, and from gfg, then 1st of January to 31st of January is the best time, right? So buy it before 31st January, because if you would complete that course in 90 days, 90% of the course you would complete in 90 days, you will get 90% refund. Okay. And guys, one more thing, that tomorrow on GFG, Geeks for Geeks, this is Gate Computer Science, GFG Gate, we have one another challenge which is GFG, on which I am taking for Gate Computer Science, Engineering Mathematics and Discrete Mathematics session. If any of you are giving Gate Computer Science, you can meet me there, so that we can solve different questions together, and we are going to solve 25 plus years of PYQs of Gate Discrete Mathematics and Engineering Mathematics of Computer Science. Okay, so it is on Geeks for Geeks channel, not this channel. This is for Gate exam, and we are going to get live from our different channel, that is Geeks for Geeks. If you will write Geeks for Geeks on YouTube, it would take you to our main channel. Okay, so ROC. Okay, so we can. I'll try to take one more class on that topic, right? Then we'll discuss that in detail. Okay, yeah. So that's all from my side. I'll try to do that as well. Okay, that's all from my side, guys. Thank you.